Hello everyone, welcome to my explanation on chapter 18, the chemistry of aryl halides, vanillic halides, and phenols. So right now we're just going over the introduction. This is kind of a roadmap for everything that we're going to go over that is important that he wants us to know from this chapter. So what are aryl halides, vanillic halides, and phenols? So first of all, let's go over this. Because when he went over this in class, I did not know. And I had to look it up just now, pretty much. Aryl refers to benzene ring. Halide refers to halogen. So an aryl halide is a halogen directly attached to a benzene ring. See, one attachment. Vanillic halide. So halide refers to halogen. Vanillic refers to double bond. Okay, go carbon-carbon double bond, and then vanillic refers to something directly attached to the double bond. So here you see we have double bond, vanillic, directly attached to double bond is the halogen, vanillic halide. Halogen on the double bond. So this is basically an alkene, as we all know. Phenol, or phenols, refer to an alcohol group, or in other words, a hydroxy group on a benzene ring. And you can have multiple different groups or types of phenols. Just know that it is a phenol if you have the OH on there. But there can be other things attached to it as well. Now, if we go over here, for these three things, none of them undergo SN1 or SN2. These are different sections of the book that tell us about how, these different structures can't undergo SN1, SN2. He skipped that, but I think it's good to know. Because, so we don't get tricked by this man. Now, if you go on in the book, there is one section that talks about nucleophilic aromatic substitution reaction. He did go over this in class, but he did not tell us, what undergoes this type of reaction. For NAS, it's only aryl halides, particularly if they are ortho or para, and particularly if they have nitro groups attached to them. Okay? So for example, it would be a nitro group plus a halogen on a benzene ring in the ortho or para position. So if you look here, I have a review of what ortho and para are. So ortho, two groups on adjacent carbons on a benzene ring. Para, two groups on opposite carbons of a benzene ring. And another little review is, alkenes, which is this right here, even though it has a halogen on it, it's still an alkene. They can undergo elimination reactions. And elimination reactions happen, for example, when you have an alkene, you remove a hydrogen, and that double bond becomes a triple bond, and so that alkene becomes an alkyne. So just keep that in mind. I'm going to go over an example to kind of review that for us, but know that elimination reactions can occur with alkenes. Alright, moving on. Other reactions that he wants us to know from this stupid chapter. Coupling reactions. There are two types that he went over. One of them is the Heck reaction. The second one is the Suzuki reaction. So coupling reactions just basically mean combining two separate compounds into one. And both of these occur via palladium 0, whatever. There's a couple ways to write this. I will show you the exact catalyst that he uses and the exact catalyst that we can use in order to combine the compounds. So for the Heck reaction, the compounds used are aryl bromide or aryl iodide, benzene with a halogen, bromide or iodide, combined with an alkene, which is just a double bond in a carbon chain. We all know this, hopefully. If you don't know, shame. I forget things too. Honestly, I did not know any of this 30 minutes before I looked at the book. But it's okay. We're learning. For the Suzuki reaction, it's an aryl or vanillic boronic acid, which is just benzene ring with a BOH2 on it. I'll show you examples with an aryl or vanillic iodide or bromide. So if you look at this part right here, iodide or bromide, it's the same thing as this part. The only difference is for the Heck, it uses an alkene, and for the Suzuki, it uses a boronic acid. So just keep that in mind when we move forward to be able to differentiate between the two, because they both use PD on C. The final reaction that he wanted us to know is a multi-step reaction, and it's how to form a boronic ester. We'll figure that out together, because I don't know yet, but we'll find out. And then last but not least, I just wrote make it make sense, because we're going to make it make sense, hopefully. And that's the introduction.